In this video, we're going to talk about content from Chapter 7 in the Murach book. Chapter 7 deals with creating our own classes. So we've have experience with creating our own methods. We've written methods. We have the main method. We've written other methods inside our class, our main class, to be able to do additional logic and extra functions. But now we're going to talk about how do we create a second class in the code. In this case, we're going to do a separate class in two different files. And so we'll have a separate file in the, we'll have two files, two .java files in our code. The reason we want to do this is because we want to be able to present more data. So we use our own data class because we want to be able to create lots and lots of data. So, if you think back to the examples we've done with gradebooks, for example, or contact forms or things like that, we want to be able to put a lot of grades and a lot of students and a lot of contacts, a lot of data into our program, and then let the user manipulate that data and act on and interact with that data in lots of interesting ways. So we do that by using classes. So typically, we talk about a three-tier application. We typically have a presentation class. In our example, these are the menus that we're writing, the main menu, the submenus, the options to allow the user to enter data, the reports that we print out. So we have a presentation class, which is really how we interact with the user. We have a business class. These are going to be our data classes. So this is where we're going to write additional class options where we're going to put a lot of data into our programs. And then we have a database tier or something that might be called persistence. This is what we do with all the data that's in our program after the program ends. And so currently when we write code, the program ends and all of our data just goes away because we're not saving it anywhere. But you would typically have a third tier here, which would be a database tier. Sometimes this might be a database. Sometimes this might be a file. Maybe it's a CSV file or something like that. In this class, in subsequent weeks, we're going to be writing our data into a CSV file when our program ends and then reading it back from the CSV file when the program begins. So that we'll have persistence of data across different executions of our program. Okay, so typically this is how you would think of a class. This class is called product. It's got three fields in it: code, description, price, and then it's got several methods: set the code, get the code, set, etc. We typically use for each field, when we declare a field, it's a variable in the program, in the code, so it's got a data type. You want to give it a good name, just like you do any other variable, and then it's going to have a getter and a setter. So in Java, this is the standard that we use. You have a method to set the code and a method to get the code. You don't always need a setter if you're not changing the code. If you're not going to set the contents of the variable code, then you don't need a setter. But you always need a getter so that the user can use that information in their program in some way. So in this case, we have three fields: code, description, price. We have a setter and a getter for each of those fields. And then we have another option here, which is to get the formatted price. So in this case, we can get the price raw as a double, or we can get it formatted as a string. Okay. You can have multiple instances of a product. So this is when we create a product, it's called creating an instance. And then you can have multiple instances. So I can have product one and product two. These are two different variables or maybe two different elements in an array list. And they're both of type product. The data type of those variables is product, but product one and product two have different values in their fields. So this is called an instance of a product, of a class. In this case, the class is named product. Okay, so here's how we declare instance variables. So whenever we declare a field, we're going to want to declare a variable in the class to save that field. And so we'll declare those fields using private. So we have up till now been declaring everything as public. When we declare instance fields for a variable, for a class, we want to declare them as private. That's because we don't want the consumer of our class, the presentation layer, to be able to use this field directly. We want to force them to use the getter and the setter methods. So that's why we make it private. And then the getter and the setter methods will be public. Okay, here's some code that describes a class. You see, we have the definition of the class: public class product. We have our instance variables: private string code, private string description. Then we're declaring methods. This is a special method called a constructor. It has the same name as the class. And this is how you create the instance. So when you call new product, this is the method that you call. It's called the constructor. In this case, it doesn't take any parameters, but typically we would write the code so that we would say, give me a new product, and we would send in as parameters, we would send the code, the description, the price, and then there'd be logic in the constructor to set those. And then these are the setters and the getters. Okay, they're all on one line, but these are methods. Notice that these are not static. They're public string get code. So it's not static because it's an instance definition of a method. This method lives in the instance. So it is a different method. The result of this method will be different for instance 1, for instance 2, for instance 3. So that's why it's not declared as static. Okay. Here's a discussion of the constructor. So the constructor so we define the class name, public class name as the constructor. The name of the constructor has to be the same name as the class, spelled exactly the same. And then we can give it a parameter list, and then we can put logic in there to do that. So here's an example of one where we're just initializing a blank product. Still no parameters being passed in, and we're just using literal values, in this case, the defaults of the data types to assign those values. This is what we'll mostly see when we implement constructors. We'll have, in this case, we have 3 variables in our instance: code, description, and price. And so we'll go ahead and pass those in as parameters to the product. And then we can set them using this type of code. When we use this dot here, this is a special notation because we have code defined here as a parameter, and we also have code defined as an instance level variable. We have to differentiate between those. So in this method, when we use just code by itself, we're using this parameter definition. When we use this dot code, we'll use the code that's defined up here outside of as an instance level variable. Okay. You can also use other variable names here, C, D, and P, instead of code, description, and price. I personally prefer this one. I think code, description, and price, that's descriptive. Those are descriptive variable names. So we can still use descriptive variable names and use the this dot to help ourselves. Here's how we define a method. We define a method in a class the same way we define a method in our presentation class. Only we leave out the static. So in this case, it's public. We have a return. It's public or private. Usually will be public. Return type. This is the data type: int, double, string, whatever that might be. The name of the method: get, set, whatever we have, parameter list, and then options, and then the statements that the method will execute. Here's the basic getters and setters. Here's a get price. Typically, the get, all it's going to do is return the data from the field. Sometimes you might want to do some formatting on it, or maybe there's some math or something that you want to do, but typically it's going to be a getter is going to be a very simple method here. Here's an example of the get price formatted, where we're actually creating a currency formatter, and then we're returning the price. This would actually return the price with the appropriate currency field, US dollar sign, euro sign, whatever the currency of the local computer is. Here's a setter. This is changing the value of the instance variable code. Okay, here's some more examples of setting values, passing literals as creating. When you create for this is the logic that would be in our presentation class. You see, we're saying product. This is a definition of a variable. So the variable name is named product with a lowercase p. It has a data type of product with an uppercase P, which matches our class name. And then we have, we set it to a new, we use the keyword new, and then we call the constructor. Here we call the constructor with 3 variables, with 3 literals rather. Here we call the constructor with 3 variables. Okay, so this is us creating an instance of the class using the new keyword. Here's how we're calling methods. Once you define a method, once you define an instance and you create an instance, you can then call the methods using the variable name dot. So product dot set code. So this product is when we created this variable here, setting it to an instance of product. then we can call a method that we define, set code, get code, whatever that is, get price. We can call that using just like we would call a method on the math class or on the scanner class or the integer class, anything like that. Okay. We can also declare static fields inside our methods, or inside our classes rather. We declare static fields using the special keyword final. The static field means that the variable cannot change. It's a constant value. So you can declare these in your data classes, just like you can declare them in your presentation mail level. If you declare a static field inside a data class, then that field will have the same value in every instance of the class. Okay, and so you don't have to initialize it when you create that. So you would only want to create a static variable or a constant if you have data that really doesn't change. Like the number of days in a month is never going to change. So that's okay to put it in a constant variable. Here's a whole example on this of defining a class. This one is called financial calculations. You can read through this and get an idea of how that works. And here's some ways that it's being used. This works basically the same as our product class. Just another example. You can also have methods inside your class that have the same name, but with different parameter strings. So in this case, we have print to console with one string parameter and print to console with no parameters. This is called overloading. And you can do this if you have, maybe you have an option print to console that's going to have different output based on the number of parameters that are being sent in. So you can do that by creating methods with the same method name in your data class, but they have to have distinct parameter lists. So in this case, this is one string, this is a string and a Boolean, and this is no parameters. So even though they have the same name, because their parameter list is different data types, then it will be they'll be separate methods. We won't really do this overloading in this class that much, but you should be aware of that as you see it in other code that you're reading. Here's how you call the overloads. And so we'll do an example in a subsequent video.